One story, preserved through a single family's papers and never independently verified, centers on a structural engineer named Thomas Vance, who worked on the construction of a major American train station in the early 1900s. According to notes his family kept for decades, Vance became convinced partway through the project that the building he was helping design had almost nothing to do with moving trains, and everything to do with something else entirely. His granddaughter donated a box of his papers to a regional historical society in 2009. Among them was a partial technical notebook, water-damaged and missing its final pages, filled with sketches that don't resemble ordinary railway engineering at all. This video is presented as alternative history storytelling built around that family account and genuine architectural history, not as a verified historical record. If stories the official record doesn't fully explain are why you're here, subscribe and turn on notification. New investigations every week. Thomas Vance trained as a structural engineer in the 1890s, a period when American cities were racing to build the grand terminal stations that would come to define the era. Soaring vaulted ceilings, cavernous concourses, domes that rivaled European cathedrals in scale. According to his family's account, Vance was hired in 1904 to work under a senior architect on one such terminal, a project he initially described in the early notebook entries as the most exciting commission of his career. The notebook, as preserved, shows a shift about 4 months into the project. Early pages contain conventional load calculations, standard steel frame specifications, ordinary engineering shorthand. Then, according to the family's account of the notebook, the entries change. Vance began sketching the building's central dome not as a roof structure, but as what he labeled, in the family's telling, a resonant chamber, complete with proportional measurements that don't match any structural requirement a train shed would need. Curved surfaces, precise geometric ratios between the dome's height and the concourse floor, and notes referencing what he called the return frequency of the hall. If this account is accurate, Vance wasn't just building a place for trains to arrive. He believed he was building an instrument. The broader architectural context here is genuinely documented and worth separating from the family story itself. The great terminal stations of this era, Grand Central, Union Station, and dozens of others across the US and Europe, were built with a level of acoustic sophistication that architectural historians openly discuss. Whispering galleries, domed ceilings engineered to carry sound across vast distances, marble floors and vaulted stone chosen partly for their acoustic properties rather than pure structural need. This part isn't speculative. Any architectural history of the period will tell you these buildings were acoustically tuned on purpose. Where the family's account departs from the mainstream explanation is in what that tuning was supposedly for. The standard explanation is straightforward. Architects of the era wanted grand public spaces where announcements could carry, where the sound of a station felt appropriately monumental for the scale of the building. Vance's notebook, according to his family, suggests he came to believe the acoustic design served a different purpose, that certain frequencies, generated by the movement of crowds, trains, and the building's own structural resonance, were being deliberately harvested by the architecture itself, in a manner his notes compare cryptically to the old system, a phrase he never explained in the surviving pages. According to the family account, Vance raised his concerns directly with the senior architect overseeing the project sometime in late 1905. What happened next is the part of the story that turned a curious notebook into a family secret. Vance was reassigned within the week, moved off the terminal project entirely, and placed on unrelated municipal work. His family's account states that he was told the reassignment was standard practice, a common enough thing on large projects. But according to the notebook's final surviving entries, Vance believed otherwise. He wrote that he had been moved before I could ask why the vaults don't line up with any train schedule ever drawn. He never worked on another major terminal project for the rest of his career. This is where the story, if taken at face value, stops being a single family's curiosity and becomes part of a much larger pattern that independent researchers into the period's architecture have pointed to for years, though it's worth being upfront that this pattern is interpreted very differently depending on who's doing the interpreting. A number of grand terminal buildings from this exact era share unusual structural features that don't map cleanly onto their stated function. Central domes positioned above concourse rather than above the actual train sheds. Underground vault systems beneath several major stations that architectural records describe only vaguely, often as utility space or mechanical access, without further detail. Foundations sunk unusually deep for buildings that, structurally, didn't need that depth to support their visible superstructure. Mainstream architectural historians have straightforward explanations for each of these individually. Deep foundations for stability on soft urban soil, underground vaults for genuine utility and maintenance access, domes placed for aesthetic and acoustic reasons already well documented. None of this requires a hidden purpose to explain. But taken together and layered against a family account like Vance's, it's exactly the kind of pattern that fuels ongoing speculation. And it's fair to say that speculation is all it currently is. This is the piece that Tartaria and Old World researchers have folded into the larger theory of a suppressed global energy grid. And it deserves the same caveat as always. It is a theory, not an established finding. The argument goes that if a network of structures once existed, tuned to draw and distribute energy through resonance and atmospheric potential, the same idea researchers point to with old star forts and Tesla's own experiments at Wardenclyffe a few years later, then the great terminal stations of the early 1900s, built at exactly the moment America's electrical infrastructure was being centralized into private utility control, could represent a later, disguised continuation of that same principle. A resonance structure built to look like ordinary civic architecture, its true function known only to a handful of the people who designed it. Mainstream historians reject this framework entirely, and it's worth saying plainly that there's no accepted scientific mechanism by which a stone and steel building could function as an energy harvesting device in the way the theory describes. Vance's family kept the notebook quietly for 3 generations. According to his granddaughter, he rarely discussed his early career at all, and when he did, he described the terminal project only as a job I didn't finish the way I wanted to. He died in 1951, having spent the rest of his working life on conventional municipal engineering. Bridges, water system, ordinary civic work with no domes, no vaults, and, as far as his surviving notebooks show, no more entries about resonant frequency or the old system. No verified evidence has ever confirmed that any train station was built for a purpose beyond transportation and civic architecture. As far as the historical record shows, Vance's notebook remains an unverified family account, and the acoustic sophistication of these buildings, while genuinely real and well documented, is fully explained by mainstream architectural history without requiring any hidden function. The story endures not because it's proven, but because a handful of oddly specific design choices in buildings from a single decade have never been fully and publicly explained, and a family kept a water-damaged notebook that raises questions it never quite answered.